How to make this truss on a manual mill with a rotary table. You're going to need a 3/4 inch square tube. I got this at Home Depot. That's aluminum. 3mm cutter. I'm not a machinist, so I know that's probably supposed to be a two flute cutter, but I did use a 4 flute and it worked. And any rotary table will do. It doesn't have to be like that one. It doesn't have to be an 8-inch rotary table, because this truss measures less than 5 inches. The origin 0, 0, X and Y, Z is not important, is the center of the rotary table is at 0x, 0y. The center of the truss is at 0x and 0y. The rotary table is set to 0 degrees, and this truss is aligned with the X axis of the mill. We're not using this rotary table at all for this project. That's a tilt axis. All these points are locations that you will put the cutter. You will, for example, let's take this window right here. No, let's take this window right here. So you would plunge at that point, and that's the location in X, and that's its location in Y. So you would plunge at this point, you would cut to this point, and then you would cut to this point, and you pull the cutter out. We're not going to do the diagonals. We're not going to do any diagonal cuts while the rotary table is set at 0 degrees. We're just going to do all of these L-shaped cuts. There are, let's see, there are, you're going to make 8 channel cuts while the rotary table is at 0 degrees. Yeah, and these are all the locations of the points where the cutter is going to plunge in and cut to. Let's see. Let's do a rotation, because all of these points are they're going to move. First, let's go to that location right there. That is 1.815x. Okay, close enough. And 0.20344 Y. Okay, again, close enough. Now you can see that the cutter will plunge in right there at that part of the window. And when we do a rotation, that point is going to move. We're going to do a rotation so that you can make the diagonal cut. We're going to align that diagonal cut with the x-axis. Okay, so let's do the rotation. On my particular rotary table, it's going to be 7 turns and 57 ticks. So, and you'll see that point's going to move. Make sure that, there we go. Okay, so Okay, that's 7 turns. And I gotta find 57 ticks. Okay. Lock that in. Now you can see the cutter is not over that point anymore. But I've done all the calculations, and this is where that point went to. Wait a minute, let me look at this again. We're talking about this point would be after rotation. It would be this. It would be this point right here. So that point is at negative 0.926 y. Oh, I'm turning the wrong one. Okay. Negative 0.926. Okay, so now you can see we got closer, and now and it's at 1.574x. Okay. Okay, now you can see the cutter is in fact right where it needs to be. And the diagonal cut is aligned with the x-axis, and that's when you would make that cut. Okay, so when you make that cut, this is where the cutter is. You would plunge in, and then you would cut to there. And that's going to have the same y value as where you plunged in, but you're going to stop at 0.89616x, and then you're going to pull the cutter out. Then you go to, actually, what I've learned from other YouTube channels is to make channel cuts with the end mill deflecting away from the parent material. So that means you would actually plunge in at this location and cut to that location, because this is the part that's going to be left behind. That's the window that we're going to cut out. That'll be removed. This will be still here, so we want to go in this direction when we make our cut. So you plunge here, pull out here, then you're going to go to this location in Y to get to this point, and there's that point's location in X. And you're going to plunge in here, and you're going to cut to that location in X. Pull the cutter out. You're going to do that for all, with this rotation. This is negative 36.86 degrees. That's clockwise. So you only have to make 1, 2, 3, 4 cuts while we're rotated this way. And then when we rotate to make the other diagonals, so when you're rotated in the negative direction or clockwise, that allows you to make, because this is going to swing down like that, and then these diagonals will be aligned with X to make the cuts. But these angles these diagonal cuts are going to require a rotation 36.86 degrees in the positive direction or counterclockwise. Also, I don't know if I mentioned, the origin is, I think I did, the origin is the center, 0x, 0y, the center of the truss. And I'm going to hover over these numbers so that you can pause the video, write the numbers down. I'll do that before the video's over. You can get all those numbers, all those locations. These locations had to be calculated because each one of these beams would be the same width. The diagonal beams will be the same as the top and bottom beams, and the vertical beams, they'll all be the same width. And you can see here that where the cutter would be here and where it would be here is a greater distance than where the cutter would be here and where it would be here. That's a right there is a less distance than that. So that all had to be calculated. And these are the numbers that'll make all of those beams equal width. Also, it's important that you use a 3mm cutter if you want them all to be the same width. You can use a different size cutter. It'll just affect the thickness of each beam differently, and they won't be equal. Okay, so the other rotation. Let me get it. Here's the other rotation. Okay, so, and actually that's the right there. That's the rotation, the full number. That's the actual full number in degrees. The rotation. So, okay, now these are all the locations to make the other diagonal cuts. So, let me see. I set a whole bunch of subdatums myself because I make a lot of mistakes, and I'm new to machining. I make a lot of mistakes, so I use subdatums. That way I'm always cutting to 0 instead of looking for a number to cut to. I've in the past gone past. I've cut right past the number where I was supposed to stop and ruin the part. So you can see here, I would set each point would be a subdatum and plunge at like that top line there says plunge at subdatum 21, cut to subdatum 22, and then cut to subdatum 23, pull out. So that's how I did that. But if you don't have a digital readout, or if you don't want to use the subdatums, you can just go to the actual the locations that I have on this paper. Okay, what else did I forget to mention here? Let me look at my notes. Okay, so you need the 3/4 inch square tube, 3mm cutter. Any rotary table will do. I also have a little 4-inch rotary table that would have done fine for this. And I'm not going to talk about how to hold work on the rotary table, because that's another subject. I'm just going to make videos about calculations and locations and where locations went after you rotate. Okay, so what else do I need to mention here? Okay, I guess I'm just going to hover over these locations so we can definitely record these locations. If anyone's going to make this part, these are the numbers you'll need. So, there we go. This point here is where you would cut off the end, and that's that number. This is all in inch, by the way. Okay, so that's where you would cut off at the end. You can see at the other end, it's the same number but negative. Okay, so let's do this. That might be a little hard to see. That's 0.20344 y, and then negative 0.20344 y. Those are the only two y locations. Okay, so that's the whole top row of x locations. Cut off. Here's the bottom row. Okay, and these are the locations after you've rotated clockwise 36.86 degrees. These are only the important locations. This is not all of them. There are only 8 locations on this whole page. So there you go. I think this is self-explanatory. There's only one y number for both of these points because they share that same y location. And same with these 2 points, they share that same y location. The x locations are circled in orange. There are 4 of them. Okay. Now these ones. Okay, one more set of numbers. It is, where'd it go? That's these numbers. Okay, this is after you've rotated counterclockwise 36.86 degrees, or that number right there, the full number. Okay. Same thing. Okay, so if you do these instructions, you'll have that piece right there. I think it's pretty neat. The end here I did a little different. I didn't cut it off right there. You can do whatever you want at the end here. You can cut it off where I gave you that number, or you do whatever you want here at the end. But I thought it was pretty neat little truss. And what else? Yeah, so one more time, while you're at 0 degrees, the only cuts you're making are the L-shaped cuts. You're going to do all of those. There's 8. There's 4 on each side of 0x. There's 4 L-shaped cuts you have to make, and then there are 1, 2, 3, 4. 4 diagonal cuts you'll make with one rotation, and 4 more with the other rotation. And yeah, that's how you do it. I want to make videos about how to do all of these projects I made. That's a pentagon. I actually used the linear drilling function to make that. There was no rotary table. And all I had to do was I had to calculate some points, and then I let the linear drilling function fill in the space between the points that I calculated. And I'll make a video how to do that. That could have been done using the linear drilling function, but I used the rotary table for that. A lot of 5-axis pieces. You saw I have that tilt axis on the machine there, and I do all these calculations myself. Anyway, there's a few pieces in here.